project was basically to design a vehicle or robot that would only receives power from light and cannot use any batteries. And the objective is to go in a predetermined pattern around a course and navigate through obstacles to gain points and make laps on a track. So in order to accomplish this, we used, you could use capacitors as storage devices. So we used capacitors as a storage device and converted the light energy into electrical energy through solar cells. And we used a diode so the capacitors would not, in between the capacitor banks and the solar panels, so that the capacitors wouldn't lose charge when we were out of light. And we used the power from the stored in the capacitors through to a microcontroller to power our microprocessor to pulse the motors to control the discharge of that stored energy. And also we had two motors, and that enabled us to turn. We had some, I guess, feeler arms that rode against the wall to detect the position of the vehicle, and we had a light sensor mounted on the solar panel that also allowed us to sense position via how many lights we went by and how strong the light was.
We had lots of late nights working in the lab here doing the testing. Oftentimes we were split up. Like I said, I was leading backup on a few things, and we were kind of partnered up. We had a team of four, so me and my partner Mauricio were usually focused on testing a certain aspect, like the software or like the power, because he was lead on the software as I was lead on the power. So we would sort of be testing one of those two, and then Bill and Chris were partnered together, sort of doing the electrical, schematic, and the physical construction of the vehicle. And so they would be working on something, and so we'd be testing some new code or something while they would be actually constructing the circuit board or actually constructing the chassis of the vehicle. So, and oftentimes, we'd be over there testing, and the vehicle would achieve would achieve a lap, and we'd be hooting and hollering in here. So it was real fun. It was easy to get distracted when especially when you achieve your goals and sometimes overreach your goals.
I was in charge of the mechanical and the navigation. So we had a solar vehicle, and the object of it was to travel a course autonomously. And so what I did was I came up with all the little gadgets and stuff that it needed to actually perform them, to get around. I built the car basically from the ground up. I learned a lot about teamwork, and actually having everyone together have a drive towards a certain goal, and everybody does their part, and all the things that you've learned throughout your college experience, as far as engineering and everything else, like it all kind of comes together in the end. And when you actually have the final finished product, you just step back and you look at it, you're like, wow, that is pretty cool,
We all would put our ideas out on the table. We had some pretty innovative ideas that came out with using reflectors to redirect the light energy to help the solar panels be able to get more energy. And we threw out some ideas, and the idea that we came up with was on one side we used a fan that would retract, that would collapse on itself, and that helped us get the reflective material up near the light while to let more energy be developed on the solar panel.
We did a lot of research and gained a lot of knowledge through the process. So I think the ability to research and learn on your own and as a team and work together and put together design was really the biggest thing that I learned.
Is it tied a lot of the classes that you took previously, prior to this, together. You had all your basic electrical classes where you learned Ohm's law and Thevenin and Norton, and it tied those principles in with your electronics and your analog classes that you had, where you had to do scaling and use the analog circuits to help take some of the outputs of your microcontroller and feed them into power in the motors. And then we used the microcontrollers class, naturally that came into play. And we used some of thermo, we used physics. It tied a lot, and of course you use your English and your lab skills from previous lab assignments in developing the paper, for the paper that goes with it.
That was a great experience. I mean, there was like kids from schools all over the Southeast, and that was a whole lot of fun, getting to see everybody's designs and what they work towards, as far as like engineering. Here at the UAB, the local competition, we had 4 teams with 4 totally different designs, and then you can just imagine that. I think there were 45 schools who entered this competition, all the different designs, and it was cool. Like, everybody walked around and took pictures of everybody else's designs, and you talk to other people, be like, wow, how did you get that to work? Or, hey, how does this work, And it's great. We go green, so we get the gold, baby. That's our motto.